My name is Steve Deeks. I'm a clinical investigator. I do a lot of cure clinical trials. I'm based in San Francisco. Probably the newest stuff is around something called shock and kill. This is where we use a drug that will force the virus out of its hiding place so that it gets expressed, so that we can see it, and then we can basically get rid of the cell that has the virus. All right? And there's two big ways that this is happening now. One is only been studied in monkeys so far, but it's using this thing called TAT. TAT, T-A-T, TAT. It's part of the HIV. So when the HIV gets into the body, it goes into these cells, it gets into, a person's DNA, and it basically becomes like a gene that a person has.
Yeah.
And part of that HIV has something called TAT. And TAT turns the HIV on so that it comes out. It's very powerful. HIV uses that. And so what we're doing now is using TAT as a drug that we can deliver with gene therapy, gets into the tissues, gets into the cells, turns on the HIV, and then the HIV gets expressed, okay? And we're doing the same thing with something called interleukin 15. And we see this in people now. So interleukin 15, which is also a drug, turns on the HIV. So that's great, okay? But that's only half the story. You don't really want to go around turning on the virus because they could just take off and cause all sorts of chaos.
Yeah, true.
So the other part of the story is the kill part. And there's a lot of excitement around something called TAC. Not TAT. TAT was T-A-T. TAC is T-A-C-K. And that's this thing that's this new drug that's very, very safe, that if it's around, whenever HIV gets turned on, the cell dies. So we now think we are going to have an approach in which we can take, a typical person with HIV that's on treatment basically has 1 million viruses left over, scattered throughout the body that we care about. And we got to find those 1 million viruses, get rid of them. And we can do that now with TAC, or IL-15, to get the virus out, and TAC to kill the cell. And the virus goes away. The thing that's going to happen is the ability to test your viral load at home in 10 minutes. I think we should have the community involved now, particularly in areas of the world where most people with HIV has, including, where you live, Kenya. And hopefully that's happening. I'm not directly involved in that development, and it's still a little bit like science fiction. But we're getting close. And it's like, it's going to be, you take a little pin, tiny little pin, you get the blood comes out into a tube, and then you use your phone, take a picture of it, and your phone tells you yes or no, you have HIV that's high or low. So that's coming. No, I'm not a big fan. I mean, when cure is on the cutting edge of science, right? AI needs existing data to analyze. So in terms of cure, where we're really advancing and coming up with science that's never been done, AI has nothing to interpret. So it's going to have to be the old-fashioned way. We were making great progress up until about a year ago, when my government decided to back down, and that's very unfortunate. But unfortunately, other countries are stepping up, and the Gates Foundation is investing heavily. So everyone in the cure business knows that the agenda has to shift from the north to the south. And the kind of cures that I think are really going to make an impact, my personal opinion, is going to be the kind of cures in which you have a person, they got HIV, and they're struggling with treatment. They want a cure, but they're not going to want to be in the hospital. They're not going to want to get things that are used for cancer. They're going to want something that's really easy and safe. And I think that there's a couple of approach is being taken, including work with the broadly neutralizing antibodies, vaccines, and some gene therapy stuff. Where, we'll have like 1 or 2 shots and boom, you're done. If I can only bet on one strategy, it's this really cool idea. You inject in your muscle like a vaccine. Okay? And in your muscle cells takes up the genetic material, a gene, and the muscle cell then starts making proteins, antibodies, that attack the HIV. And they're doing this now in monkeys, and we hope to start doing it in people, but you can give 1 shot and the muscle becomes a protein factory. It just starts cranking out this protein, these antibodies. They go around the body and kill the HIV. It's like getting all your HIV drugs for 20 years from a single shot to a muscle. Be patient. Fortunately, treatment is getting better and better. We're going to have options to get people like once a year. The cure is not coming tomorrow, but there's global commitment to making this work.